All right, I want to continue with factoring the greatest common factor. On our previous video, we introduced what factoring is, took our time with the very first one in pulling out the greatest common factor, and we know that we can check it because factoring is just the opposite of multiplying. So if I wanted to actually multiply out my answer, I should get my original, and I do. That's how I know it's right. I ended on this one, which was kind of quick. I want to do this one again, much like I did the other one. So if I do 15 uv to the 6th minus 10 u squared v to the 5th, I can write this in factors, in prime factors, and this in prime factors. Well, 15 is 3 times 5 u and then 6 v's, 3, 4, 5, 6, minus 10, which is 2 times 5, 2 u's, 1, 2, and then 5 v's, 1, 2, 3, 4, 5. All right, now if I want to find the greatest common factor between these two terms, let's see here. In both of them, I have a 5. In both of them, I have 1 u. In both of them, I have 1, 2, 3, 4. Let me erase that so I don't mess that up. There are actually 5 here, and there are 5 here. Now, I know I have more than 5 in this first one, but what's common to both is just 5 of them. Right? And so when I write this out, I have a 5, a u, and 5 v's. That's common to both. Now, what's left? Well, in this one, I have a 3 and a v. Let me bring down the minus. And in this one, I have a 2 and a u. And so when I look at this, I can break it down into common factors, prime factors, see which ones are common. When I pull out that whole product of those common factors, because remember, factors just mean things multiply together, I should say. When I pull out all of those factors, there they are. I still have some stuff left. I can check this by distributing this. I'm not going to, but you can check it, and you'll see that you get this. Let's take a look at another one. And let's see if we can do this one a little more quickly. You could do it in the prime factors way. Let's think about it in terms of numbers. Let's consider the 12 and the 8. What's the greatest common factor between those two? Looks like a 4. Let's look at the x's. There are 2 x's here, 2 x's here. What's the most I can come out of both? Well, 2 x's. What about the y's? I have 7 here. I have 6 here. What's the most that can come out of both of them? Well, I can pull 6 out of both of them. All right. So with that said, that's my greatest common factor. Now let me see what's left. 4 times what gives me 12? 3. Well, if I had 2 x's and I pulled out 2 x's, I don't have any left. I had 7 y's. I pulled out 6 of them. I still have 1 left. So that's just taking care of this first term after pulling out this common factor. Let me bring down this subtraction. Do the same thing. If I had an 8, I pull out a factor of 4, I still have a factor of 2. Or in other words, 4 times what gives me 8. Now let's look at the x's. I had 2 x's, I pulled out 2 x's, I don't have any more x's. Now what about this thing? I had 6 y's and I pulled out 6 y's, I don't have any more y's. I am done. I should always check to see if I can pull anything else out of here. I have a 3y and a 2. There are no common factors between those two, so I know that I'm done. Now I can check that by distributing, but I'm not going to. You may do that. Now with the time left, I'm going to see if I can do this the long way, just for those of you who need to see that. 12x squared y to the 7th, and I may run out of time, so I'm going to speed up here. 12 can be written as 2 times 2 times 3, x, and then 7 y's. 1, 2, 3, 4, 5. What? That's not what I meant. Oh, I'm not going to make it. 1, 2, 3, 4, 5, 6, 7. And then I have that 8, which is 2 times 2 times 2. And then I have 2 x's and then 6 y's. 3, 4, 5, 6. If you look at that, what you'll be able to see is that I have a common 2, a 2, I have 2 x's, and then I have